Hello, good day. Welcome back. Please join me in to learn another session, and I hope you are all revising everything well and catching up with all the concepts so far, so you are more familiar with the usage of different registers and how the bus connections are, from which peripheral to connect and talk to the microcontroller, etc. If not, please go back and revise, and this will help you to understand more with the coming lessons. Today is day 15. As we learn part 1, today it's USART part 2, and we're going to learn about USART receiver, how to write a program of USART receiver. These are all the sections you will learn today. What is an UART? You already know, and I'm going to give you a small recap about what is an UART and the difference between USART and UART, and then you're going to learn everything about the steps to write the USART receive program, and also followed by every line instructions from scratch. You will write the code. So let's get in. Before jumping in, I would like to introduce whom I am representing. I am representing A2Digi. It's a startup by Anbukarasu brothers, my brother Alex and myself Arul in 2023. Both of us gathered over 20 plus years experience in the industry, and we would really like to put you out there to help you all so that you can also be molded into a better version of you, to be a better professional. And if you are having to build your website, please do contact Alex. He is the expert in building the website, and he would be able to build any kind of website. So if you want to do your own personal portfolio website, then he can set you up with that. So please do go to A2Digi and you can send your inquiries, and he will be able to help you. Our mission is to convey our experience and our knowledge to at least 100,000 upcoming professionals through online course. And the main advantage is you don't have to go to a face-to-face class. You can study at your own pace wherever you are. That means even on your mobile phone, all you need to have is a internet connection, and you can access to our course content. So it is very easy to do, so please, that's one of our major advantage, and we are bringing it out there to help you all out there. A little bit about me. I am Arul Prakash Anbukarasu. You can call me as Arul or API, as persistent as I would like to be, to share my knowledge with you all, so you can also be molded into a better professional. I have 20 plus years of experience working in various industries in few countries in Australia, Italy, Singapore, and in India, majoring on those industries: renewable energy sector in solar and wind energy conversions, power systems on lead acid batteries, network embedded systems on ATMs, teller cash registers and point of sales, banking automation systems, and smart parking operations. Majoring my expertise is in these three domain: embedded systems, VLSI, and project management. That's why I'm in a stage now I would like to share my knowledge and experience to you all out there, so it will be much useful for you to make yourself a better version of you. A little announcements to make. I categorized into two different categories. One is the YouTube viewers. In order to get a free certificate, you have to watch at least 28 classes. At the end of each and every videos that I'm going to upload in A2Digi YouTube channel, you can go there and you can watch it. At the end of every YouTube video channel of those clips, there will be a short attendance form. So please fill in your details and send it across to us, and that will count for your eligibility for your free certificate. As part of YouTube regulations, the videos can't live there for longer, so it has to be removed by 2 days or 3 days. So in case if you have missed a session, if you want to go and recap, unfortunately you can't. I'm sorry about that, but that's why I strongly recommend you to join in one of our internship programs. And what do the internship professionals will get and lead to? You will get to acquire an internship certificate. and that's worth a lot. When you get into the first job working with senior engineers, the product managers and the program managers will value your 30 days experience. That means they don't have to give you basic training, because you already know what is all involved in embedded programming and embedded system design, so you will blend easily into any team. So that's why they treat this as a big value. And not only that, you will get your own login, so you can log into our learning management system portal to go through each day session. And also, after you watch particular video and click on complete, that will add you to your that day's attendance, so you don't have to worry about going to YouTube and filling the YouTube attendance links. Not only that, you will get access unlimited times to the course contents. That means you would be able to download all the PDF materials, the source codes, and all the reference manuals, the data sheet, etc. And also, you could pause the videos and you can come back and rewatch it again, rewind or forward, whatever it is, it's all yours, and you can do it. And if you feel like you get stuck anywhere, please contact our backend support. They are a lovely, friendly team, and they would be able to help you to make you proceed along with your learning. These are all the materials required for you to learn, and the more hands-on experience you create, the more you will learn, and it's more easier to follow. If you haven't bought the materials already, please do contact Pantex Solutions. They are a big manufacturing company, and they would be able to help you to acquire all of this. And you need all of this to do this course study really well. And not only here, you can take all of this and you can create your own design and your own project. So it is money worth well spent. So please do contact Pantex Solutions, and they would be able to help you. Okay, you learned about how to transmit a data now yesterday or the previous session, and now are you keen to know how you can receive the data as well through user communication? Okay, shall we continue? Let's get in and find out. As you all know by now, UART stands for Universal Asynchronous Receiver and Transmitter. It is also called in the industry or by other experts as serial port, COM port, RS-232 or RS-485. These are all the terms in the real industry you will hear most of the time. So when they say RS-232, that means they're really talking about serial communication protocol. RS-485, again, it's a serial communication protocol. It is the most widely and commonly used, and it is very simple because it requires only 3 wires: the transmitter, the receiver, and the ground. So through those 3 pins, you can transmit and receive the data. It is useful for communication between a microcontroller to other microcontroller, or from microcontroller to PCs, or from a microcontroller to FPGA sensor, etc. So USART is out there and it is very easy to use. So that's why it's one of the communication protocol that if you want to interface with microcontrollers. And as you learned the other session, there is 2 different modes of communication. There is a synchronous mode and asynchronous mode communication. And the USART is nothing but USART is nothing but it's universal synchronous asynchronous receiver transmitter. So what it does is, in the USART, you don't need a clock to send through a data. In asynchronous, you can transfer a byte data in the frame structure, but you need extra bits to transfer. That means you need to have a start bit and a stop bit, and also the parity bit. That means it needs a little bit more memory allocations. Whereas in synchronous form of communication, the data has to be synced with the clock signal. So therefore, you can transfer bulk data through synchronous communication, but you need a clock. So this is the basic difference between UART and USART, between synchronous and asynchronous. So we already learned about transmit yesterday or the previous session. We're going to learn today about the how you're going to write the receive function of it. So that is what here it's the explanation about, as you learned from the other session, so I don't have to be a repeat again. So this is the 2 different modes of communication, synchronous and asynchronous. This is one typical example. We covered this already, but I'm just giving you a recap. So in order to connect Xilinx FPGA sensor, the UART module, to your host PC UART module, it has to be in a cross connection, meaning this UART transmit pin has to be connected to this UART receive pin, and this UART transmit pin has to be connected to this UART receive pin. So that's why it's a cross connection, because transmit to receive, transmit to receive. So it's a cross connection. Otherwise, you can't communicate. And also the other main thing is you need to maintain the constant speed on both UARTs, meaning you have to set both the UART on the same baud rate. Baud rate is nothing but bits transferred per seconds. So if it is the most standard out there is 9600, sorry. If you set this as 9600, then you have to set this as 9600. Otherwise, you can't transmit and receive data. So that's one of the key. And these are all the parameters we learned yesterday. Those you already not familiar, go back and watch the session, and you'll know about all the parameters. And these are all the steps today we're going to learn about to write the USART receive from scratch. As you know, you got to tell the microcontroller which port you are using. So you need to enable the clock access of GPIO-A, and that is there in RCC, reset counter clock. So you need to go and reset and set the enable there. And also you got to enable the clock access to UART2. That's the second step. And also you need to set the PA2 as the alternate function mode for transmit, and PA3 for receive. And also you need to configure the baud rate, and you need to use control register 1 to transmit and receive data, which you will learn today. And these are all the basic steps that you have to cover. And this is the reference manual. If you go to the reference manual, you will see this in page 15, or I can show from the data sheet. If you go to page this is the reference manual. So we learned yesterday or the other session, this is a microcontroller and it's communicating connection via the bus AHB bus matrix, and it's connected to AHB1. The AHB1 is communicated via the GPIO port A. So we're going to use GPIO port A, and we are using in this study USART2. So that means we're going to use transmit and receive. So both has to be set as the PA2 for transmit and PA3 for receive. So that's the functional block diagram. I'll minimize that. So if you zoom in, this is where the USART lives. USART1 is there, USART6 is there, and this is the USART2, and we are using USART2 for our program today. And as you know by now, there are associated GPIOs where you have to configure those pins as USART, because you got to set the output mode. You can use the same port as an input, as an output, or an alternate function, or an analog function. In this case, we are learning about USART function, so you need to set that pin as alternate function. For you already know, PA2 stands for port A pin 2 stands for USART2 transmit, and port A pin 3 stands for USART receive pin. So you need to configure that. And this is what, if you see in there, that's what we're going to program today. And this is again in the reference manual to set the alternate function PA2 and PA3. For every port, you can set that and use for multi-purpose, meaning the same port can be used for timers, it can be used for SPI, it can be used for I2C, etc. But we are using for USART2, so it is on alternate function mapping AF7. So PA2 is for transmit and PA3 is for receive. And I'm going to show you data transmit and receive via a LED blink. So the LED is connected to port A5 and it is on the schematics. If we go to schematics, you can see, I'm not sure whether I have the schematics for you here to show, but just give me 1 sec so I can see if I can get you the schematics. Okay, I'll show you the schematics as well. Okay, so if you see PA5, this PA5 is connecting to PA5. So if you scroll down, it's a green LED from linking the LED, remember the LD2 green, so that's connected to D13 and D13 is connected to PA5. So we're going to register that as well. And we need to classify the alternate function because you are setting up for USART2. That means you have to use that being port A, pin 2 and 7. It's an alternate function 7. So you got to use this as 0, 1, 1, 1. So it's between bits 0 to 7. So it is, that's why it's alternate function register low. If it is from bits 8 to 15, you have to use the alternate function H high. And you know, we already discussed about how to calculate baud rate, and the peripheral clock is 16 megahertz. Baud rate we're going to set as 9600. So this is the value you calculate with this baud rate register formula, and you will end up with this value, and you need to convert that to hex value, and this is the one you're going to load to the register in the program. And today we're going to learn about USART write and read to transmit and receive. For the USART transmit, you need to enable first the bit 7 transmit data register empty. You need to send us 1. So this is set by the hardware, and by the content of the transmit data register it can be transferred to the shift register, and from there the data register will fetch the data and show you the data. And to read, you have to set the transmit enable and USART enable as well. So that's why these addresses are. I'll explain to you in the program. And this is the data register. This is where you get to see the data, and it retrieves the data and show you in the output as an example. Okay, let's move in and get into the code today. So I'll just minimize this, and I'll open the IDE, and let's go from there. I already opened the IDE. If you'd like, I'll give you a short break, so go and enjoy that break, and after you come back, we'll start from scratch, and I'll show you how to set the registers, and you're going to learn line by line all the coding that you needed to know. So yeah, don't go anywhere, please come back, and we're going to learn, and we're going to see the output in the Arduino IDE, and also with the LED blink as well. We're going to write the program and make sure this LED blinks on and off. Okay, go and enjoy that break. I'll see you back shortly. Catch you then.